Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Ladies and gentlemen, welcome back to another live stream. Okay, going to share the link to the stream. Please make sure to join my server so you can participate in voting for the next live streams, and also you get notified about live streams. So there you go. Nice. Where is in the Zig server? Okay, nice. All right, well, just going to wait for people to join in. Just going to wait for a bit there. Other than that, today we're going to try something very new to me. I never tried that, so we're going to try it live pretty much. Pretty much. All right, making sure everything is good. Right, nice. All right, just going to wait for interested people to join in, and we're going to start our adventure. Our adventure. Alrighty. So today we're going to try something very new that I never tried before. Which is about the X window system protocol with Unix socket, and of course in Zig. That's gonna be very interesting. Hopefully I won't get stuck. We'll see. Alright, so this is pretty much the X window system protocol. I also got some other resources that I found through the internet. There is this juice box thing. It's a tiled window manager written in Zig with no dependencies. There you go, that's what I'm talking about. It is implementation with the X protocol is written from scratch, and instead provides handy features to make it easier for the developer to work with while still remaining low level. And there is also this answer on Stack Overflow that I found right here, opening sockets to the X server directly. So there is a bit of an answer there, right there. So, and also there is an example using the C language, X11 socket. There you go. Minimal example of directly talking to the X server instead of using a library like Xlib or XCB. So pretty much I think we're going to use these resources to try to make something and try to understand how the X11 protocol works. And so yeah, but because if you know that XCB and Xlib are pretty much just, you know, just helper libraries, but at the end of the day they're just there to help you you know, talk with the X server. They're just using X11 sockets, you know, at the end of the day. So pretty much. Right, so I think we're just gonna wait just a bit more for interested people to join in, and we're going to start. So around 4 minutes already. Gotta wait just a bit more. And yeah, while we're waiting for people to join in, I think I'm going to install Zig and VS Code, since I just installed Linux again. For VS Code, I'm going to install from the AUR. Hold on a second. VS Code, where is it? Okay, see VS Code AUR. Arch Linux. Where is it? Oops, what I'm doing. AUR Arch Linux. Let's go. And yeah, Visual Studio Code bin. It's called that name. Alright. And this is PAMAC. There you go, bin. Let's install that package, the AUR package. And let me type in my pass. Right. Hold on, I'm just gonna mute the microphone for a second. Alright, let's go. Now it's building Visual Studio Code. Nice, we also need Zig. So Arch Linux Zig. Well, there you go. I think VS Code is installed now. I just need Zig now. This is 0.10. No, I want 0.11. There's Zig dev bin here. Zig dev bin. Yeah, I think that's probably what I need though. Okay, build, apply, and hopefully it wouldn't ask me for the password once again. There you go. This is the stable release, but I actually need the latest version basically. And let's try to run Visual Studio Code. There you go. Hello Marty Flowers, welcome back to the live stream. How is it going? Right. Got a lot of stuff to explore today. I'll see how it goes. Alright, so I think I installed Zig right now. Let me check. There you go. I have the latest Zig right now, just like that, and I have VS Code installed now. Now I'm just gonna install the Zig extension. Zig language install ZLS and what else? Okay, let me see what is going on here. I maybe need the C++ compiler. I'm not sure about that, but probably. The debugger IntelliSense, also the debug. Yeah, the debugger, right? But anyways, what else? Let's see. Language support, GitLens. Okay, let's go with that one. That's interesting. CMake. I don't think I need CMake, at least not now. C++ themes. All right. Okay, well, what about Framer? Something like that. There you go, Framer Dark. I like this theme, so I'm going to install that one. And there you go, there you go, there you go. And we also got GitLens. We also want error lens. And I think that's all I need, really. Yeah, I think so. Alright, so I guess we could start the project right now. Okay. Let me go inside documents. And then I'm just going to create a directory for Zig. And then I'm going to create a new directory for new project. And mkdir. So I'm going to call the project, I guess, Zig X11. Okay, zig X11, let's go. And yeah, now let us open the folder, documents, zig, open. Yep, and there you go. Oh, what the? No, hold on. cd zig X11 code point. All right, there you go. So we're inside of here right now. Zig init dash exe, and right now we have this stuff. I guess use zig in path. We recommend enabling ZLS. Enable. Can't you use though the ZLS of the package manager? Well, yeah, I think so. I mean, okay, hold on. Let me actually put in my pass. There you go. And yeah, and I actually mute my microphone before typing a password. I recommend that just in case, because the keys can have you know unique sounds. So I mean, if someone is really interested into your password, they may be able to figure it out. So using the proper tools. Okay, let me see. It's built in ZLS zig git. Alright, starting build. It seems like it's built in ZLS. Interesting. I'm not sure how much it would take. Starting build. Okay, I'm just gonna put it on the side, I guess, until it's done. Okay, so right now we are in source. I'm going to remove this stuff, get your main function there, and there you go. All right, again, I need to get to settings, actually, preferences, settings. Let's look for zoom. Again, I'm not sure why this is not a default. And save. Oh, it seems like ZLS is done. Okay, format on save, and that's pretty much it, I believe. And there you go. ZLS seems like it's done, which is interesting. Now I'm not sure how to make it use the system ZLS instead. Interesting. The server is up. Let me relaunch VS Code. Let's see. Settings maybe. Extensions. Zig. Zig language server. Oops. Zig. Check for update. Built-in path. ZLS. Bin maybe? There you go. There you go. So I'm going to try to use, I think, let's see. I guess ls or file, for example, /bin/zls. There you go. So this is the actual path. So let's put in the path there. /bin/zls. And that should hopefully work it out. I'm just going to restart just in case. And let's go ahead and try that. Seems all good now, I guess. And now let's try this out. Now there is the possibility of using XCB, just like this, I believe. C import, and then you would just say C include, I believe, /xcb.h. There you go. And then, well, I'll just call that C. And then it would basically say C dot, well, XCB connect, etc. And there you go. Now I could basically use XCB instead of using X11 directly and trying to implement it yourself. But today we're going to try, I did try XCB before, but today I'd like to try live how to actually communicate and talk with the X server directly without XCB, without Xlib. Because XCB and Xlib are just helper libraries. And for my future projects, I don't really need like the whole XCB library, etc., like the whole X11 stuff. I just need this really little subset of it. So we're gonna see how it turns out. Okay, so let's start by first of all creating a client, I believe. But before that, actually, let's start by creating general purpose allocator. And is equal to cd.heap general purpose allocator .config. Defer general purpose allocator.dinit. Of course, is cd.debug.assert, right, to make sure we're not having any memory leaks. It should be equal to OK, and defer should be first, of course. Defer, there you go. Now let's actually get an allocator there. General purpose allocator.allocator, let's go. So we got a general purpose allocator right now. Nice. Next up, let's try to create, I guess, a client. Oh, by the way, this should be variable. Okay. Now let's try to create a client. Is equal to cd.http.client .init. No, you do it like this, and then you give an allocator. And there you go. Now I believe maybe you say .init or something like that. Maybe not. Okay. Let's see, defer client.dinit. And yeah, I'm not sure if we can make it constant. So zig build run. And let's see. Yep, it needs to be variable. And there you go. Right now we're creating a HTTP client. Now I could hopefully try to figure out how to communicate with the socket. Or actually, maybe I don't need a client. Maybe I need, not sure though. Let's see. Client dot. Oh yeah, there's connect. Now we could connect. There's the host, the port, and the protocol. The host, the port, and the protocol. So I have a little example here that I found on the web, which is this guy right here, Juicebox. Let's see how they did it. Where is it? X11, there you go. And then connection.zig, I believe. And let's see how they did it. Let's find out. Connection, right, setup exid.init. Well, I think I've seen it somewhere around here though. Let me have a look. Maybe protocol? I don't think. This probably holds in some structs and stuff. Yeah. Not this one. Maybe context? Or X11. One of these guys. There's a connection. No. It's probably somewhere around here. Connect to the X11 server. There you go. Okay, what is going on in here? Parse display. Let's see where they're using parse display. They're using it actually here. Open display. There you go. So they're trying to mimic Xlib basically here. Interestingly. Oh, they're actually using .NET.connect Unix socket. Not sure if I can actually use the client here, but we're just gonna go with that one, honestly. Why not? Okay, let's see. Var socket is equal to std.net.unix socket. Yeah, connect Unix socket, and then here you give it some path. Here it's given it a socket path, and it's actually saying buff print path buff /temp/ that stuff. Display. Interesting. So in fact, I need to find this guy. Hold on a second. Where can I find that? /tmp /.x. There you go, X11-Unix, and then /x. Oops. There you go. There's only one there, X0. And in fact, if we look into echo display, there is 0 right here. So we should connect to this guy. For now, I'm just going to hard code it. I don't care. /tmp /x11-unix /x0. So in fact, what he have here, display.display, is basically either 0, 1, 2, whatever. I could probably maybe get that from the environment variable. But right now, if it works, let it be. So the first socket.uk.dinit, is that how it works? Let's see if that's successful or not. Probably need to try this. Yep, and it actually gives me a stream. Well, no field or member function named dinit and net.stream. Really, net.stream. Close socket. There is a close. Oh yeah. Dot close. You say dot close, just like a file. In fact, on Linux, everything is a file. So let's see if this actually works. There you go. Nice. Now let's figure out what we could do with this socket. We could read, write. That's pretty much all we could do. So we need right now to figure out how we can work with the protocol, basically. The protocol is the document that will tell us how to do this. So let's try to just see for now the source code of this guy. So right now I think we connected to the Unix protocol. then I believe we need to authenticate with block. Okay, nice. And then we connect. All right, let's see what is that authenticate does. Authenticates with the X11 server by retrieving the authentication details from the environment. Nice. So if os.get-env x authority try fs.open file absolute xo file name. Okay, it's looking up this environment variable though. Okay, let's see what we got there. There you go, /gmp/x. Oh, okay. For now, I'm just gonna hard code these values. So it's basically opening that file, open file absolute, and then also getting the home environment variable, and it's opening that directory, and it's trying to open the file x authority. So it's basically trying to open slash, actually not that, let's see. Well, I'm already in home, so I could just say .x authority. There you go. X11 authority data. Nice, nice, nice. Nice, nice, nice. So it's basically getting the reader of that file, and then os get host name. It's getting the host name to this buffer, host name max. Interesting. While true var auth read int big. I think that means big Indian. So it's reading the U16, then it's reading the string, which is the address, and it's reading again another string, which is gonna be the number. Then you have the name, a string, data string, and also auth family address, number, name, data. Interesting. If mem.equal u6 u8 host name auth.address, then return auth, else it's just deinitializing that guy and it's continuing somewhere. Well, this is an actual infinite loop, seems like, interestingly. Yeah, breaks. I think it basically retries. Yeah, I guess it retries var auth. Interesting. Okay, let's try to do this. So first of all, we need to get the env authority. Okay. So const authority file x authority is equal to std.fs.open absolute, I guess. Open file absolute. The absolute path is, I believe, os.get-env, or is it? Yeah. Then here you give it a string of what is that called? It's x authority. And could that fail or something? Yeah, it could. Or it's either optional or it could fail. Probably optional, I guess. But anyways, I'm going to assume that maybe it's an optional, but we'll see how it goes. But what happens if it doesn't? Oh, I see. So if it found that X authority, then it actually read that. Otherwise, it just tries to open the home directory, then opens that file. Interesting. Now flags, of course, I think none for now. And yeah. Oh, I see why it didn't actually autocomplete. It's cd.os.getinv. Yeah, it's optional, null terminated string. Interesting. So here X authority seems like cool. Const X authority. Now what's next? We got the file, hopefully. Now I think we basically going to, seems like we're getting the host name here. First of all, we need to declare a buffer. Cool. Var let's see, host name, I believe. Host name buffer. Okay. cd.os.host name maximum. Interestingly, u8 equal to undefined. So basically an initialized, not non-initialized buffer. An initialized buffer. Anyways, so what's going on here, by the way? In used. Oh, I should actually close this, by the way, when I'm done with it. Defer X authority.close. There you go. Now hostname buffer, we need to basically, oh, I've done hello no tukes, no bugs, welcome to the live stream. Oh, I have done this as well. In the end, I switched to build an XCB from source with zig and muscle, so it is statically linked with no runtime dependencies. Very interesting indeed. But I think it probably wasn't an easy task to build XCB too. So yeah, I'm not really sure if I want to use this manually on my future projects, but either way, this is gonna be just a learning exercise for me, and I'd like to basically share my experience with other people who are interested. So yeah, I'm just actually exploring this for my first time, and I'm going to see how practical it would be to actually use this in production code. We'll see how it goes. But until now, it's all fine, but we still haven't even connected correctly yet. But it's pretty clear until now. So yeah. So try os.get hostname. So const hostname equal to scd.os.get hostname. Right, name buffer. Hostname buffer, interesting. So actually I should give it an address so it could basically write to that. But what it actually gives me here, weird. Const hostname. Oh, so it's basically gonna be using that buffer to basically get the thing, but then it would give me an actual string. Yeah, it took some time. The hello world XCB binary with text rendering and rectangle was only 75 kilobytes static. But yeah, it's a good learning experience, and pure zig X11 is cool. Yeah, it's very cool to actually use only zig for everything. That would be interesting. So yeah, pretty much. Okay, I'm not sure what is a host name. I mean, I know what the concept of a host name is, but I'm not sure what that would be yet. So let's actually have a look into that. Print line, or oh yeah, print. So print, there you go, host name. Let's see how that goes. And expected type const u8. Oh yeah, let me actually just for now just do that, just assume that it's there. And in fact, I guess maybe I have to error union. Cannot format slice without a specifier. Yeah, it's probably a string. Enigma. Okay, nice. So it's basically the name of that I assigned to my computer. Interesting. I think I understand now. All right, so right now it seems like it's basically reading some data from the actual stream of the actual file. Okay, gotcha. So I'm not sure where I could actually find that in the protocol. Maybe I could look for XAuth or something like that. I never used this. Doesn't seem like it's here. But anyway, let's just follow up with the source code for now. So yeah. Yep. Alright, so first of all we gotta read the family. So I wonder though if you could just basically make a little struct and then use zig meta programming to actually like get all the data for that struct. By the way, this hostname is only for Unix domain socket connection on Linux. On Mac you have to do something different, and for TCP connection you have to get remote hostname. I looked at the pure Python X11 library instead of looking at the X11 documentation. Ooh, pure Python to learn how to do it. Interesting. Didn't think about that. So pure Python X11 library. Pure Python X11 library. I think Python Xlib. The main part of the code. So the Python X library is intended to be a fully functional X client library for Python programs. It is written entirely in Python, in contrast to earlier X libraries for Python, the ancient X extension, and the newer. Alright, interesting. This is possible to do since X client programs. Alright, gotcha. Nice. Let me have a look. Where is start? Xlib examples, probably here, I guess. And x.py or probably display or xauth or connection. Yeah, probably xauth is what I need in my case here. And this is how they're doing it. They're getting the environment X authority just like the zig code is doing. If file name is none, so yeah, gotcha, just like the zig code basically. Interesting. And here they're basically reading through that data. Now to learn how to do, okay, so yeah, they're doing basically the exact same thing, but I think the zig code though is much better, like much more readable than the Python code. But one thing that I'd maybe like to try to do, instead of trying to basically kind of hard code that, maybe we could figure out some meta programming stuff to do that. Not sure, we'll see. So maybe const auth, not sure what to call it, maybe authentication info. And then maybe it could be a struct, and it's basically a U16, that's the family. And then there's basically 1, 2, 3, 4 strings. The first one is address, then the number, name, data. Okay, address, number, name, data. Address, number, name, data. All of which are actual strings, which I think it would basically be a slice maybe of U8s. Right. I should probably make it const though. And yeah, there you go. So we got the authentication info struct. I'm not sure if I'm supposed to do something special for the data type of the family since it's actually big Indian. I don't think so, for now at least, but anyway. So that's it for that one. Now let's try to figure out maybe some meta programming to do it. I'm not sure if I can do it. I didn't do meta programming for a very long time, but let's see. So I think type info, yep, and then you basically give it the struct. Honestly, structs, I'd like to call them like this. Okay, the types, authentication info, and I believe dot fields, if I remember. I mean, hold on, zig type of type info. I think it was in built-in, possibly. Do not remember the source code where exactly it was. I think built-in, but let's see. Type. Oh, there you go. There you go, I found it. Okay, nice. I need to look for pubconst. Oops. Pubconst struct. There you go. So for structs, it basically gives you all of this information. Layout, back in integer, fields, decals is tuple. I think what I'm interested into right now is fields, which is basically a slice of struct fields. And this is the struct field. It gives you the name of the struct, the type of the struct, the default value of the struct is comp time and alignment. Interesting. So let's try to go through that, I guess. Dot fields. So we got the fields. Now how do you actually go through it? I guess for loop. And then I could capture the field, I think, and now I could basically take the name, for example. Now just for testing, I'm going to actually try to print the name. So s and then field.name, and let's find out how that goes. No field named fields in union built-in type. Oh, I need to actually access the struct field union member. So okay, I guess maybe something like this, maybe. Not sure. I guess like this. Values of type must become time known, but index value is runtime known. What? Maybe I gotta make this comp time, I guess, or something like that. Inline, maybe. Don't really remember. There you go. Nice, nice, nice. Let's actually add a new line, I think. And there you go. There you go. We got a family, address, number, name, and data, which are basically the names of this struct. Alright, I gotta go now, but one thing you can do later on is to use the XCB proto files XML to generate the zig X11 structs and functions. Doesn't include connect and XAuth. Oh, just like the Wayland library. Generate the XCB proto files. I think I do remember the XCB library though. So hold on, XCB library. I think they was using GitLab instead of GitHub. There you go, libxcb. And just for the people that are interested, here's the link posted on the chat. And the XCB library is generated from the XCB proto files. Yeah, interesting. Where is it? src proto. Maybe a source? No. Nope. Doesn't seem like. Let me have a look. Proto. Where exactly they are. Maybe doc. Nope, that's just documentation. M4. Nope. Man, not sure where I can find the proto files. Hold on. Maybe I could look for proto. XCB proto. Nice. I think this is it. There you go. Interesting. So, yeah, that one. YouTube removed my comment. Oh yeah, because it's a link. Interesting. Just going to send this to for anyone interested. Reg CB Proto. And that's pretty much it for that one. Now, what is going on? See ya. See ya. No tukes, no bugs. Thank you for tuning in and thank you for the information. Okay. Xproto. GLX, present, record, render, shape, sync, XCB. Okay. Okay, so this is the Xproto header XML protocol, right? In XML format, of course. So basically, let's see, it's encoded in UTF-8. So it's a header, it's equal to Xproto. Now here are core protocol types. First of all, we have a struct called char2b, then a field of type, what is that, cardiate, what the, do they mean like, I don't know, field type cardiate, weird. Byte 1 and then byte 2, that's the names. And then there's also an XID type. There's window, pixmap. These are just integers if I remember. And then there's XID union drawable. It's either a window or a pixmap. Font table, either font or gcontext. The old names and the new names. Oh, interesting. And then there's a struct named point and rectangle and 16. All right, interesting. So you could basically use this to kind of auto-generate your structs, the structs that you need to talk with the X server, I think. And that's pretty nice. But for now, I'm just going to do everything manual, I guess. But that could be useful later on. But right now, let's go back to our beautiful meta programming. So as you can see, we actually have gone through the authentication info struct fields. And as you can see, we were able to actually print each and every field name from the struct: family, address, number, name, data. Now we have also access to type. If you actually look into here, we have the type and also even the default value. Okay, well, let's try to actually use that to get the information we need to actually construct a struct. In fact, I don't really remember how do you do that. Type comtime info. Oh, I think you fill in the type stuff. std built-in type. I think maybe you say .struct if I remember. And then basically, I guess you give it the fields. Yeah, I think it's kind of like in reverse, basically. Or can't I just do simply maybe, let's see, const authentication info. Maybe var auth info is equal to authentication info. Okay. And then maybe I could fill that up. Auth info.data address. I guess you could use field here. And then basically give it here auth info. And then here the field name, which is field.name, is equal to okay, and here I could basically give it some value depending on the field. Now the thing is, depending on the type, so we're basically going to switch, I believe, on the type. So switch on field dot type, and I guess, and then how can I actually switch on it? Like, do I do it like this, for example? I think so. So if it's a U16, then I could basically, I guess, say xauthority dot read int. Oh, read what? No, read. What is it? What was it? Hold on. Where is the guy? There you go. Read int big. Read. Actually, I need the stream first. How do you get the stream? The reader. Okay, he got a reader first. So let's actually get a reader there. Const xauthority reader is equal xauthority dot reader. I maybe need to make it a variable though, but yeah. Okay. Reader dot read int big, and then here give it a type. Oh, I see. Now I guess I could basically give it, how do I actually, yeah, I think I could just say field.type. Right? Unless maybe I can even maybe like, how can I actually basically take all the integers kind of thing? Alright, let's actually figure it out. I mean, if field.type, I guess, is int or something like that. Don't remember how to do that. I guess std.meta is, or maybe it's some sort of don't really, how to check if a zig type is int. Don't remember how do you do that. Or maybe it's inside std.math. No, it doesn't seem like. Let me just see std.meta int type active tag alignment is error string to enum. I do remember it somewhere, but okay, well, let me go to documentation of Zig standard. Is interpreted. Well, actually not that. The documentation Zig reference, std reference, I believe. Documentation. There you go. And let's try to find out maybe if there's like a, there you go, it's integral. Alright, I think it's in trait. There you go. Is nice. There you go. That's what I'm talking about. So you say is integral, then you give it field.type. And there you go. So if it's integral, then we could basically use that guy. So xauthority reader dot read int comp time t type is field.type, of course. Indianese is, I believe, .big, isn't it? Where is the code? There you go. Read int big. Oh, it's actually using read int big there. Okay, interesting. And then I basically give it the type, which is field.type again. And that's pretty much it. Otherwise I could say const type is equal field.type. But you know what? Well, no need for that one. Okay, so if it's integral, then we're going to read an int big, and then we get the actual type. Now, otherwise, if it's how do you actually do that in Zig? I guess else if maybe. Else if it's basically a string. I'm not sure if there's a trait for that. Is Zig string. Interesting. Maybe that's what we need there. And I may need though comp time here or an inline there or something like that. But anyway. So if it's a Zig string, then we're actually going to go ahead and say authority reader.read string. How did it? Oh, try read string. But where is read string? Interesting. Read int big. So it's basically getting the length, which is the first integer, u16. Then it's actually getting a try GB. So it's basically allocating a buffer of that length. And then it's read no AOF. I think it's basically reading until the last character, or actually reading until the buffer is done. Right. Interesting. So we kind of need some kind of recursive kind of generation thing, because basically right here we kind of have like const string is equal to a struct, and then basically you have can I say it's basically a len u16 kind of, and then you have a buffer afterwards. But no, let's just handle it like kind of like a primitive kind of thing, just like they have done it. So yeah, I'm just gonna say read string for now, just like how they have done it. And honestly, I'm just going to copy this. There is no need to redo it, as I understand already what is they are doing there. Read no AOF. But though, where is read? Oops, what is read no AOF? Just want to make sure I'm understanding that one. If the number read would be smaller than buff.len, error.end of stream is returned instead. Okay, interesting, lovely. All right, so read string, and then you actually give it the, I believe, the allocator first of all, and then the stream, which is our authority reader. Oopsies. I believe that's it, maybe. Pointless discard of local constant. Okay. And yeah, that's pretty much it. Else we just have a comp time kind of compile error and type not supported or not serializable or whatever you can call it. Anyway, type not supported, I guess. And there you go. So we're just gonna throw in compile error, meaning that we didn't handle that type yet. Right now though, we only have one struct. So yeah, pretty much I think probably need to kind of make this into its own function. And let's see. Yeah, I should call it deserialize. I mean, this is kind of a process called deserialize. So deserialize, and you basically, I believe, get a struct, right? So what to call it? Let's see. Let's just call it T, I guess, which is gonna be a type, of course. Comp time, I think. Comp time T type. And yeah, maybe I could say this. Yeah, struct. Then maybe I could just replace those guys with the struct. And here I would basically return for you an instantiation of that struct. And yeah, pretty much. Now, of course, you need to give me a reader. So reader is cd dot, not sure where it is cd dot, maybe fmt. No, let's have a look where it's actually defined. IO makes sense. Oops, is that the actual type? I guess. And I also need the allocator, or an allocator. Let's get an allocator too. Cd dot mem dot allocator. Let's go. And the stream in our case is, there you go, that one. So I think that's pretty much it, hopefully, if I don't have any error there. I probably need a comp time here. Probably. But, or an inline actually, maybe an inline. I don't know, we'll see. So yeah, and equal to, now here we need the value though. Hold on, we need the actual value. So yeah, this would give me the actual string. Nice. And by the way, this should be a cd.mem.allocator. Other than that, what we should do, yep, equal to, now this we should try this out. And in fact, we could basically make some sort of a label here, I guess. And use for loop label, there you go. Interesting. So I think I'm gonna do something like this. Oops. Then I'm gonna put it here, I think. Oh, what I'm doing? No, this one. And in fact, this should be inside of this guy. And am I doing this right? Where's the label? Oh, my bad. Let's actually put it here, I guess. Oh. Where can I put it? Hold on. Zig docs. Let's have a look into labeled for. Where is it? Outer. Well, not labeled for. I'd like to kind of break basically. There you go, you do it like this. So break. Then I guess you need to put it in a block by its own maybe. And then I think you basically could break. Something like this. Then basically we're giving back the string. I think so. Break, and then the same thing here, I believe. And yeah, pretty much. Otherwise, we have a compile error. So I think hopefully that should work out. Let's see if that would go well or not. So const authentication info is equal to deserialize authentication info. Here you give it the reader, which is the X authority reader, and then the allocator. Not sure if this would work, but we'll find out. Hopefully it would. Let's see. Okay, let's try to build this. Okay, expected type found fn comp time. So it is expecting struct, reader, and allocator. I give it the struct, and I also give it the reader and the allocator. So what's the problem? Expected type found fn comp time type. Comp time type? What? Comp time any type. What? Deserialize reader is cd.io .reader. Yeah, I'm giving it reader. What's wrong? Allocator comp time struct reader. No idea what's wrong here. Comp time. Should this be comp time maybe or something? I don't think. No. Weird. Weird. Well, let's see. Reader. CDIO allocator. Weird. Super weird. Well, hold on. Let me close the window. Okay, back. Alright, no idea why this doesn't work. Expected type. Deserialize authentication info. Can this be a struct maybe or something like that? No. Doesn't seem like. Oh. Oh, actually this is a function. My bad. How do we actually make it an actual type, I guess? Hold on. Well, I could too simply look into reader. What it gives. It gives a reader. Oh, there you go. It's inside IO. It's actually calling it, I guess. But no, it's not calling it here. That's super weird. io.reader file. Really? Context file. Read error. Very weird. I see what's going on here, but oh, io.reader file read error. Interesting. But where is that file? I guess it's just a struct. But really, how do you actually just take a reader, like a general or generic reader? Weird. Hold on a second, let me search about that. Zig reader type? That's super weird. That's super weird. But I guess I could do something for now as a workaround, which is to simply give it the actual file and it would get the reader from it, I think. So yeah, probably that's what I'm going to do in this case, honestly. xcd.std.fs. Oh, can I say no? So I'm just going to take the file. Then I'm going to get from a reader for now, because I can't really figure out how you could do that. So file.reader, and let's go. And I think that's pretty much it. Now just make sure to actually, instead of giving it an X authority reader, I could just give it the actual file. And it would get a reader by its own. Now, missing struct field address, etc., etc. Interestingly, okay, so I actually should, I need to either give it a default value or basically construct the type from scratch instead of using this kind of method. I'm not sure about that one. I guess maybe for now I'll make it just optional. Let me see how to construct a type in Zig. I don't really exactly remember how to do that. How to construct a type in Zig. I do remember there was like Vulkan Zig was doing something like that. This binding. Let me have a look if I can find it. Hopefully. And XML index build Vulkan generator. Do not remember where exactly I've seen that. Let's see. I have looked into I think I actually probably seen it in well, where I've seen that. No, I think I've seen it in the generated file though. Yeah, I think I've seen it in the generated file. So real quickly, I'm going to basically copy this over. I'm just going to try to generate this real quick. So git clone. Oops. Because I remember at least that one was using such a thing. Hopefully I can, let me see, cd Vulkan Zig. Okay, now I could basically use Zig out. So first of all, let me build the project. And then I'm going to say zig-out. /bin/generator. I mean, come on. Now that's not really important. What is important? Did you build my binary there? There you go, generator. And then path to vacay.xml. I could just basically use the path that is inside of the examples. Okay, examples /vacay.xml. What's funny is that I'm the one who wrote this stuff. Anyways, okay, what's else? There is what we need else. There's output path. Okay, just generate it inside of vacay.zig here. And let's see, ls. And can you just open that with code? Open. There you go. Nice. And let's see if I can find out where they're actually doing that. Type info. Hold on. Type. Okay, I need to look for where they're using type. There you go. There you go. Here's how to do it. So you too simply do type, and then you do the struct. Give it the layout. In this case, they just said auto. Give it the fields, the decals, and then is tuple. Okay, where's fields and where's all that stuff? Here, do you have fields len type struct field interesting? Okay, let's try to do that. Var fields is equal to fields len. Hold on, let me just copy this over. Fields. Now we do have the fields len, I believe. We could just take it from, well, in fact, I'm going to take the type info. Then I'm going to put it in an actual variable so it's easier to deal with. And there you go. Now I could basically say, in fact, I actually need the fields. So struct. But anyway, now here, what do you mean by std type? What is type? Oh, it's in built-in. So maybe I have to actually import built-in too, right? Const built-in is equal to import built-in. And then maybe I could say built-in dot type dot struct field, maybe equal undefined. Now I do need an index though. Okay, 0 point for that field, and then use if and declared identifier auth info. And oh, in fact, the fields length is type info dot fields dot len. There you go. Where is auth info here? Oh yeah, we do not have that now. So we gotta remove this stuff. We gotta actually say fields I, basically the index, is equal to that stuff. Now hopefully that would work. Okay, how to construct that thing? So let me just return this. So at the end of the day, you need to return this guy, basically a new type. Is it? Do we really need want to return a new type though? What? I don't know if that actually would work. Really? Well, that's actually returning the type. What? What? That is super weird. Yeah, it's actually creating a type though. My bad. Alright, that's not exactly what we want, yeah. It's not exactly what we want. Go back. Go back. My bad. Okay, let's go back a bit there. Okay. I guess I'm just going to make this optional, honestly, or give it some defaults. Yeah, maybe give it some defaults, I think. Equal to 0, maybe. Can you just do something like this? Number, that. Would that work out now? Let's find out. Okay, consider convert error union. Oh, I see. I guess I should try this out. And let's try it again. Alright, so struct declared here. Now expected type main.authentication info. Main authentication info. And found type info, type of reader. What? Really? No, it should actually be this. Auth info field.name, not authentication info struct itself. Weird. Weird. Well. How in the world? That's another level. Well, let's see. Break init value. So what's the problem? It's pointing out to here. Well. Weird. Maybe I could say const data just to make sure and basically put that guy here. What? Expected type main authentication info. But why it's pointing up to here? Weird. Field type. Error union error set. Oh my god. That function can error, I think. And expected type mem.allocator found mem.allocator. Yeah, I think it what? Why have that like that? That's super weird. Read int big. Hold on, let me go back to the code that we have here. Okay, so how did he have done it? Yeah, I just added the asterisk there for some reason. I'm not sure how you would need, why you would need a pointer to an allocator instead of just an allocator, but yeah, okay. Expected type found. All right, so right now I just gotta pass the address to that guy. Now, seems like this is gonna be a variable. I really don't understand why that should be a pointer to an allocator instead of, because in fact, this allocator thing is just a v-table, you know, just a bunch of function pointers to another allocator, which is in this case general purpose allocator. So when you're passing the pointer to an actual allocator like that, you're actually given access to the function or whatever to actually edit those function pointers for whatever reason. Super weird, but okay. Consider using try catch or if. Yeah, this should be tried. Expected type U16 found U8. Well, first of all, I don't need this variable anymore. Let me go to the documentation. Inline if, I guess. I do remember maybe there's somehow to actually make that if condition comp time. That may be the reason why there is a problem, I mean. What about inline? Okay, so there's an inline switch, an inline while, an inline for. Interesting. But the thing is, I need to actually call a function in the switch. I'm not sure if you're able to do it in a switch. But let's just, I guess, make sure to do it in a switch then. Let me just try one more time. So comp time. I don't think it's this way. Really don't think. Yeah. Okay, well, let's actually try to make this into a switch statement, I think. Inline switch. No, let me just try to figure out the error first of all. Let me try to figure out the error more. Let's see. So it's expected type U16 found a string here. Read string. Expected type U16 found string. Else if. Maybe I can do it like this. Type not supported. Okay. What about comp time here? There you go, I guess. So value of type U16 ignored. In line 4. What? Well, it shouldn't actually go to here. It should go to this field thing. Weird. Oh, but I could just, I see what's going on here, I guess. So maybe we could just remove these guys and just say this. I guess? No. I mean, we do need the field though. Weird. I'll go back. Let me try to read the error again. Value of type U16 ignored. why it is ignored. So I think it's, oh well, I see. I need to add that label, I guess. So function with no void return type implicitly returns. So implicitly returns oh yeah, I need to return auth info. Interesting. Okay. Zig build run now. And it's kind of working out, but we got a runtime error now. Well, let's see. Memory address leaked. Okay, we got some memory leak somewhere. So I'm closing the file. Get host name. Deserialize. Oh, read string actually allocates memory. Well, that's interesting. Alloc file type error deferred screen. Okay, interesting. So I actually gotta free the memory. How to do that? I think I could do something similar to a deserialize function and just go in and whatever string I find, just, you know, like free it up. Otherwise, I could do something other than that, which is, let's see, deserialize. Instead of maybe giving it this kind of allocator, which is just passing it to read string, I could actually pass in a area allocator. So I could create some kind of area allocator, arena allocator, scd.mem.arena, I guess. Oh, heap.arena allocator init, and here the child allocator, which is, you know, allocator. I guess I should try that. Maybe? No, doesn't seem like. Defer arena allocator.dinit, and it should probably be variable though. And then I could just simply pass in here arena allocator.allocator. And yeah, I guess that should work now. Cast, discard, const qualifier. Oh yeah. So I guess I could make that const again, but here var arena. I guess I'm gonna call this heap arena allocator or something, just so I can discriminate between them. Arena allocator is equal to, in fact, should be variable. Heap arena allocator, which is so weird. I have no idea why that's the case, but yeah, what I gotta say. Okay, let's try this out. There you go. Now it seems to be working out. So how I fix the problem is, instead of trying to figure out how I can actually de-initialize those strings, you know, one by one, what I did basically is just to basically create an arena allocator of my general purpose allocator, and then I passed that to the allocator, and that would be used to actually create the strings, right? To allocate the strings. And then basically when the arena allocator get de-initialized, all the strings that got allocated using it would go away, would just go away with the arena allocator. And like the general purpose allocator, which would actually result in a memory leak. So that's interesting. Now the actual question, did it actually work? Did it semantically worked? Or let's see. So let's try to print something. This is the first time, by the way, that I did such a thing, like serialization using zigcom time stuff. Anyway, let's try maybe name. It's a string. Let's see. There you go. Nice. It was actually successful. Now we're actually not hard coding the decoding of structs. We just create a struct, like for example here, authentication info. We pass it to this deserialize function, which too simply goes ahead, reads through the types and the names of the fields, etc. And depending on what type, it actually reads something. So for example here, if it's an integral type, it uses read int big. Otherwise, if it's a zig string, it reads string. Pretty amazing stuff. So I think we have done it. That is very amazing. Zig is zig comp time is very useful for serializing stuff, and as you can see, it's working pretty well. Amazing. Now let me go back to the source code though. Where is it? No need for this anymore, I think. Where is it? There you go. So what is doing next? What it is doing next? Let's see. There you go. Read string. So as you can see right here, this repo, whatever, this code uses, basically it's kind of like just hard coding the deserialization. Right now we just automated that kind of using zig comp time. So yeah, pretty cool. Pretty cool. In fact, when does it actually freeze that stuff? That's the real deal. Where does it freeze it? I'm not sure, but anyway, who cares? So what else? It's also, so let's have a look into where the guy is. So here you go. It's getting the host name, but what is it using it for? Yeah, it's checking if mem.equal host name is equal to the auth address, then it returning auth. Otherwise, it's continuing. So it's retrying again. Retrying again. So I guess it would actually read another struct. Oh, I see. So in my case, I guess I have only one X authority thing, I guess. Kind of like one interface or one connection or something like that. So it was just fine. The first struct that we have read, the first data that we have read was of my own host, kind of. But I guess maybe there could be like multiple of these. So that's why maybe they have like a while loop here, an infinite while loop. And if they find the correct host name address thing, then they're returning it. Otherwise, they're just continuing, which means they're going to retry to do the same exact thing once again. That's very interesting. That's very interesting. But for now, for the sake of simplicity, I think we're just going to leave it, maybe. Honestly, it's not that hard, I guess. Let me try to do it while true. Okay, so you got the authentication info, and then basically we're going to check if let's see, so if std.mem.eql, the type is u8, and a, let's say, host name, and then authentication info dot address, I guess, and then basically we're going to return authentication info. Oops. Well, in fact, here we don't have a what is it called? A function. Actually, we have a loop. So we have to say const authentication info is equal to that, I guess. Then here I could maybe say break authentication info. Otherwise, it's basically de-initializing GPA. Oh yeah, it's actually going ahead and basically deallocating the strings that it have allocated before. I see. Oh yeah, it's also have that struct by making its own dinit function too simply. Interesting. Interesting. But we could do it in the same way that we have done the deserialize function, I guess. Maybe fn, maybe deallocate all strings. And then of course comptime struct type, I guess. Isn't it? And actually you really need the actual struct, isn't it? So can we do something like this though? I guess. Or in fact, maybe we could say any type too simply. Yeah, I think we could say any type. And then we could, let me see. If I said any type, and then maybe I could say, in fact, I need comp time here. And then what it will return? Well, it will return nothing, none. And in fact, you also need the allocator. There you go. Now what we should do, we should basically go through all the fields. And now the thing is, I don't need this. And it basically if expected after declaration. Not sure what it's talking about here. I guess this one. There you go. Okay. Okay, now I'm really here. Had to do some stuff. All right, Marty Flowers, welcome back. Okay, so just to update you, we have created a deserialized function that basically takes any type, like you know, for example, here we're giving it a struct later on, and then it takes a file and allocator. It could take a reader though, any reader, but I couldn't figure out how to actually make it a reader instead of a file. There's some weird stuff there, but anyway, so we're taking a file and an allocator, and here basically goes through all fields and it deserializes stuff up from the reader. And then basically you could use it here, deserialize, give it the struct, which is in this case authentication info, and then you give it the file, the allocator, and it basically reads all that stuff in. Pretty interesting. So we do not have to hard code deserialization. It's just done for us. We just automated that one. I'm kind of surprised that I actually got that working. That's very interesting. Anyway, right now I'm trying to basically get any type, like some any struct, right? And then basically go through all of its strings and deallocate them. Right. So instead of is integral though, we probably need is zig string. Yep. So if it's a string, if the field is a string, then we're going to actually go ahead and say, let's see, type info struct. Type info, well, in fact, here I should say type of s. Oops. Type of s. There you go. So we're getting the type of that s, and then we're getting the type info of it. I once used the X11 API to take pixels from the screen and then send fake input. I made a bot that made me a lot of points in the game. Interesting. Yeah, X11 is not very secure. You could all do a bunch of crazy stuff for any application, and it just does it. So yeah, and used function parameter. Okay, so allocator.free, I believe, isn't it? Yep, exactly. And then here I could just take in, I believe, the field, and the field is s, and the actual field name is, well, field.name. And I guess that's maybe it. Yeah, I guess so. Now let me try to basically, when that happens, else, we can basically deallocate all strings. Comp time s, authentication info in this, oops, authentication info and then the allocator. Can it error though? I don't think. Yeah, no. So that's interesting. Deallocate all strings. So basically, if it's the right host, then we basically break out of the while loop and we give it the authentication info deserialized struct. Otherwise, we deallocate all strings and we basically continue. I don't think we need continue, although if you want to be explicit, you can do that, I guess. But anyway, let's try and see if this actually works out. Runtime, oh, it doesn't have to be comp time though. Remove that. I guess that should work. There you go. It seems all good. Seems all good. Interesting. So let me just make sure that still works out just fine. Authentication info.address, for example. And there you go. It actually works. There you go. You have gave me the Enigma address. All right, amazing. Perfect. Perfect. Lovely. So right now we basically have created a function that goes ahead, you give it whatever struct, and it too simply goes ahead and deallocates all the strings inside of that struct. So that's pretty wild. Okay, cool. Well, what's next? So right now we basically have kind of done this authenticate function to some degree ourselves. Now let's find out what's the next step. Okay. Auth.dinit connect. All right, so right now it's using connect, giving it the allocator, the stream, and the auth thing. Is the auth thing is what we need? Right, exactly. Okay, let's have a look into how connect works. That would be the next step. So creates a new connection and write the screen setup to the server and then reads and parses it from the response. All right. Let's see what it does. std.onet.stream. Oh. Go back. I think I figured out something. Hold on. Where is it? No, I don't think that's it. No. Well. What? Hold on. File? What are you talking about? Oh, because it is in fact a file. Okay, gotcha, mate. No. Never mind. Okay. Connect. Okay, so right now what we should do. So it's basically creating a struct called connection. Now hold on, I'm going to just open the window. It's so hot in here. Thanks for letting me know. Oh my god, I forgot to actually enable my microphone. There you go. Forgot to enable my microphone. So where I was, well, I don't think I've said anything critical for now, but basically right now I just gotta look into write setup function, writes the string to ask for the display setup. Cool. So here it's creating an array of 3 elements called pad, and then self.send protocol.setup request. I'm not sure what pads are, but we'll see. Hopefully we can figure it out later on. Self.send protocol.setup request. .nameLen int cast u16 auth name.len. So I guess, hold on a second, honestly I'd like to see the whole struct. That would be amazing, and see all of the info right there. I'm not sure if it does contain some sensitive data though. I'm not sure. Let me just in case, I'm going to look into the output here. In fact, it's not even readable anyways. Family, hold on, let me actually go through it step by step. Authentication info address, I know what that is. There's a number, a name, and there's also some data. Yeah, there is the name. That's nothing really fancy there. What about data? Data is just some kind of binary, I guess. Alright. Well, let me have a look. Just going to research something real quick. Well, I'm not sure if it contains any sensitive data, honestly. But anyways. Pretty much just the data. I'm not sure what's that for, but we'll see how it goes. Anyway, so it's getting the name.length and the data.length. It's casting it to u16s and try self.send. Then it's sending the auth.name, then send pad 0 up to xpad auth.name.len, and then it's sending auth.data, and then it's sending again pad 0 to xpad. What xpad does though? That's weird. What xpad does? Okay, it does some pretty wild magic here. No idea what's that. Bitcast usize minus what? Minus % bitcast, and then it's ending it with a 3. I would guess that's some magic for the X11 API. I may find some information about it though. I don't know. If anyone knows what this is, let me know, please. Thanks. Let's see. Hopefully we could find something about that. There doesn't seem to be anything like that. What about the xproto? No. What about the here? What about this guy? Is there anything about xpad? Doesn't really seem like though. What about yeah, it doesn't seem like the whole document doesn't seem like there's anything about xpad. Interesting. But anyway, I think I'm just going to copy that over for now. I have no idea what's that for. but we're just going to use it anyways. Oops. Oh yeah, the new change. So this would change into, oopsies, what happened there? As usize bitcast that. Alright, so stdfmt have changed that to some other format. This is the new way of doing it basically. But anyway, so I guess this code is outdated maybe. Isn't it? Let me have a look. Yeah, pretty much it not having it wasn't touched from 2021. Well, that's interesting. That's interesting. But anyway, I'm glad stdfmt did that for me automatically. Hopefully that works, but we'll see nonetheless. But basically, it seems like somehow it's sending either 1, 2, or 3 zeros depending on the length of the name or the data of the string basically. At least that's what I understood. Now how send works, that's the real deal. How send function works, what it does. Where is it? There you go. So it's saying if type of data is equal to a string, a zig string, or type of data is equal, well, yeah, if it's a zig string, then self.stream.writer.write all data. Okay. Otherwise, it's writing all mem.as bytes data. Okay, so if it's a string, it's basically using it directly with write all for some reason. Otherwise, oh, well, it doesn't have to be a string though. It basically an array of U8s, which could be a string, right? Oh, interesting. Okay. And then otherwise it's using mem as bytes. So it's turning that data into bytes if it's not. If it's not bytes, then it's turning it into bytes. And then it's sending it over the socket. Cool. Pretty cool stuff. We could actually make such a function. Let's go ahead and do it, I guess. Fn send, and it basically takes in a connection. In my case, I don't have any connection yet, but I have a stream. So std.net.stream, there you go. And what else? And of course the data, which could be any type. And then what it does return, either an error or none. Okay, cool. Now we basically could switch on type of data or check what it is. Okay, so if std.meta.trait.is zig string, but let me check the actual thing that they're doing here. Only pointer types can be strings, no optionals. So all of this are possible. Cool. Check for CV qualifiers. Simple check. Cool. So I guess I would just go with this for now, unless if it's proven that it's not totally correct. But anyway, so if std.meta.trait is string data, then what we could do, we could say stream.write all. Here you give it the bytes and data, I think, pretty much. I mean, what's write all takes though? Yeah, it basically takes const U8. Interesting. Else stream. Okay, stream.write all std.mem.as bytes, and you basically give it the pointer to the data, or yeah, basically. And yeah, I think that's pretty much it. Cool. All right, what's next? Now, let's actually try to figure out that thing that we were doing earlier. Where is it? Connect function, I think. Right setup, yeah, we were in the right setup function. Okay. So we could try to figure out some way again to actually serialize this data. Now, instead of deserializing, in this case, serializing this data, and yeah, trying to send it basically afterwards. I'm not sure if I can do that though. But first of all, we have a setup request though, that it's gotta be U16 and then the data length U16. Not sure I could do that. Honestly, for now, we're just gonna do it manually. We're not gonna use Zig Magic for now. So I'm just going to try to copy this guy, and I'm gonna call this fn right setup maybe. Or you know what? Let's just do it in line for now, I think. Okay, so we have this bad thing here, and here we just use send directly. Now we're not importing any protocol thing here. We could probably just copy the protocol struct there, but no need honestly. Let's just define this. So struct setup request const setup request equals struct. Let's go. And then the first thing we have is name len, which is a U16. And then a data len, which is also U16. Pretty much. Auth. Auth is authentication info in our case, I believe, isn't it? Yes, exactly. Okay, cool. And then we're sending the name. We're sending the name length, of course, through xpad. We're basically sending some zeros, but how much zeros we send depends on this xpad formula thing. Depends on the name len and data len. No idea what xpad is yet. Couldn't really find any resources about that. Okay, cool. I think this should work out. Maybe. Let's find out. So expected 2 arguments found 1. Oh yeah, I gotta actually give it the stream, which is not the live stream, but this guy, I guess. Yep, the socket. So socket comma let's see if that would work now. Enable to resolve comp time value. Oh, it's actually we need to give it the type of that data, not the data itself. Expected type const u8 found main. Yeah, probably I need to say comp time though. Consider using try. Oh yeah. And there you go. And it seems to be working, although I don't know if it semantically works. But at least it's compiling and running without, you know, runtime errors. Okay, so supposedly we have written the setup to the protocol, to the socket, sorry, to the X11 socket or the X socket, I'm not sure what to call it, anyway, to ask for the display setup. So basically right now we have written to the stream to ask for the display setup. Next up, we probably gotta read the setup, basically I believe maybe the actual response. So reads the setup response from the connection, which is then parsed and saved in the connection. It's probably meaning the connection struct. Okay, const stream is getting the reader. Then const setup generic extern struct. I think it probably needs this extern because it's going to send it over the socket. Okay. So status U8 path 0 5 U8 and then length U16. By the way though, maybe xpad, hold on a second, hold on. What if I just said pad instead? Couldn't really find anything interesting there. Okay, well, let's go back. There you go. So we have setup generic, status U8 path 0 and length. Then we have a header try stream.read struct setup generic. Interesting. What? Is really there is a read struct function? Interesting. Well, couldn't not we just used it before for deserializing the authentication info thing? I don't know. Interesting. Okay. Or maybe it can't have maybe strings, possibly. I don't know. Anyways, we'll see. Setup buffer. So here it's allocating U8 header.length. Yeah, times 4. Then okay, read no AF, so it's reading the whole to the whole buffer. And then self.status switch header.status. So if it's 0, that means it's setup failed. 1, okay. 2, authenticate. Otherwise, you got an invalid status. If it's okay, then we're trying to self-parse setup buffer. So you basically get the setup as a buffer, then you gotta parse it up. And here's how it parses it. Oh my god. That's a lot going on right there. Parses the setup received from the connection into separate struct types. Interesting. Parse setup type. So all of this is just for the connection. Hopefully the other stuff is a little bit easier, but yeah. All of this is parsing the connection. Weird. Okay. So here it's parsing the setup type. Setup. Self.setup connection.setup. But what parse setup type does though? Parse setup type. But honestly, let's just do this stuff here. I'm just going to copy this. There's nothing really to understand there. Read the setup response from the connection, which is then parse and save in the connection. So okay, let's just try to do this. And basically here, instead of stream, we have a socket. I think, no, socket.reader, just like that. And then of course here we have just, you know, allocator.alloc, allocator.free, and here's status equals switch header.status. I don't care about that, but what I care about is is it okay or not? Setup failed. Authenticated. For now, I'm just going to basically assert that it's okay. Okay. So how to do that? setup buffer, I believe, no, header dot status is equal to 1. So if it's 1, then it's okay. Okay, let me see if that actually works out. So we got a failure, end of stream. Interesting. Why that's the case? So let me make sure we're doing this right. Authentication info. So where we're actually calling this guy. Here, I guess. There you go. So it's writing setup, then it's immediately after that it's reading the setup. Cool. Okay, let me just revisit write setup again, just to make sure I'm not missing anything. And it's basically doing the stuff that we've done before, right? This. Yeah. So I guess it should work. I don't really. External struct status, pad 0, length is trying to read the string, and then it's having a setup buffer, try allocator.alloc, u8, header.length time 4. Not sure why it's times 4. Error defer allocator.free, I don't need that for now. Right, in fact, it shouldn't be error defer, it should be defer. And try stream read no AF, setup buffer. Interesting. End of stream. Let me try again. Still, same problem. I'm not sure what times 4 is. 4? Again, failure. End of stream. Now I have no idea why that's failing. So it's basically not getting enough data from the stream to actually fill in the setup buffer, the allocated setup buffer, for some reason. Not sure why that's the case. Self.reader. What? Connection. Is this connection? I would guess. Yeah. It returns to the connection socket reader. Dot context equal to self. What the? Self. Weird. Oh, there is a read function here. std.os.read self.stream.handle buffer. Ooh. Oh well, it's not the actual. They're doing it like this. Seems like interesting. Okay, well. Now the thing is this read no AOF needs to set up buffer. So it shouldn't be stream here, it should be this guy. Interesting. Well, I'm just going to real quick try to create that reader thing. Try to replicate it. Connection reader struct. Oh, what I'm doing? Const connection reader, and it seems like to be able to do that, you have to basically define these guys. In fact, let's just call it connection. And then here you have a read error kind of thing, which is this for some reason. Weird. And this is the thing that I couldn't figure out before, how to actually create a reader. And I don't really know why it have to be this complicated. Weird. But anyway, read. So stdos.read self.stream.handle. Well, I do not have that stream in, but I should do that. So the field is, well, in fact, let me put it, I'm not sure where to put it. Let's go put it here, I guess. So this would be cd.net, I guess, .stream, there you go. And then maybe I need an init function, or we could just go ahead and create it. Cool. Cool. Interesting. So let's actually create a connection. .stream is equal to socket, and now basically I have to say connection.reader. That's the actual stream, and hopefully it would work now. I guess it should be variable variable. So expected type error, blah 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 blah. Function return type declared here. Error.net name detected, not remember destination. Error set. Weird. Can I just remove it? Oh, I don't think I can, because you're defining it here. Can't I just tell it everything, I guess? Error or whatever. Doesn't seem like. Weird. I never actually done such a reader thing. Oh well. Error.net name deleted. Though, hold on a second. Can't I just use file error, read error maybe? I mean, it's saying something here. Same error set as a cd.fs.file, but why not put it? Well, can't I just do this and this? What? Alright, that seems to fix it. But I have no idea why it's still saying end of stream. Oh. Self.stream .write all. No idea at this point. So I don't think I need this anymore. Still same problem. Well, weird. Alright, well. I honestly don't know what's going on here, what's wrong. So I think we're ending this adventure here. I'm not sure what to do next on this one. Otherwise, maybe we could try to look up other resources, but yeah, I think I should probably look this up in like off camera. This seems so hairy. But we at least learned some things. So yeah, I think that was it for this live stream. I may actually do a live stream after this one, but of course changing the topic maybe to Vulkan or something, but we'll see how it goes. So yeah, that was it for this live stream, and see you later everyone. Goodbye, thank you for watching.